So, this is the first video I recorded on my laptop, so I don't know how it's going to work out. But today I'm going to talk about black holes and the Big Bang. So, just some light entertainment. And gravity. So, we've all watched Interstellar, I'm sure. And the thing about gravity, which Interstellar, they did their research in the science parts and stuff, and they tried to make it as real as possible so that it didn't look stupid. And what happened is that when he was coming, there was is it Gargantua, isn't it, the supermassive black hole. And of course they pick supermassive black holes because they think that it's less spaghettification, whatever that is. I mean, it's where basically you get stretched because of the gravity. And so they, scientists presume that a person can withstand that because the supermassive black hole is more gentler as you go in, I guess. So that's why I guess they portray a supermassive black hole in the film. Now, what they do is they show how the time differencing works, because they show it from the perspective of the person, but I think both, you kind of get both perspectives, don't you? So they are orbiting Gargantua as a way of trying to get into the planet, and then they go in from their orbit to the planets to try and understand what's happened to the planets, and then they come back out again. And the guy who is in the spaceship that's still orbiting, he is waiting for them. And so you get the idea of the passage of time, the relative passage of time. It portrays that very well. So the guy in the spaceship, basically, he's been there, I can't remember how, it's like 30 years or something, I think it is. And he's 60. So the guys go down to the planet, I think it's the water planet, isn't it? Yeah. And they're down there, and the film portrays them being down there for, I don't know, a few hours maybe. And this is the water where they've got that continuous wave going around the planet, and it's they've discovered that basically the person who landed on that planet had, from their perspective, the person who landed's perspective, had only been there like a day or so ago. You see, even though it's been decades since the person was launched, from their perspective it's only a day or so, you see. And so they go down there and they found all the wreckages together. They are assuming it's going to be strewn everywhere, but they were like, obviously not, it's only just happened from their perspective, you see. And so they coming to the planet decades later, but the person who's on the planet, it's only been a day, I guess, or something like that, since they landed, you see. And then you get it again. So they go down to the water planet, don't they? And the black guy, stays in the space shuttle, the orbiter. And so they go down to the planet. They're there for like an hour or so, a couple of hours maybe, I think. I don't know what the time is, but it's short, less than a day. And they come back and the guy's aged 30 years. So the guy who's on the outside, time past 30 years, they go towards the black hole, right? Right, so their perspective, if he's on the outside, if he could actually see them going down to the black hole, he'd see it like a time slowed down thing. He would see them as if somebody's got a high-speed camera and slowed it down so that, if you could see the, and then they're coming back as well. And they'd speed up as they came back. So they'd go down, and if you could actually see them, they'd be really slowly moving like this. And he would be normal. And on the other hand, from their perspective, they could actually see out to the orbiter as it was going round, right? It would be like he was on fast forward. He would be moving really, really quickly, and of course, blurred and stuff, right? So it visualizes that perspective and realizes that perspective, which is pretty good. Now, if you think about it, so there you go. So from an outside perspective, right, from like our, as if it were, remote perspective, things that are towards in a black hole go slower. And obviously we're not talking about, you know, just a step event sort of thing, or you cross over a boundary as such. It's just as you get closer, time slows down, so it's proportional. And so as you get closer and closer to a black hole, right, then from an external perspective the time has slowed down, and from an internal perspective the rest of the universe is going much faster, you see, right? So there's the black hole, right, and here we are. So as you get closer and closer to the black hole, somebody like me observing from the outside, as you get closer and closer to the black hole, you slow down. So eventually, right, you're getting to the point where you're going so slowly, right, and time on the outside is passing so quickly, right? And of course, if you extrapolate that to the, just looking at my experiment outside, got electric van converting. If you extrapolate that, then obviously the centre of a black hole is supposed to be a singularity, isn't it? Now that's the key. In other words, you're talking about infinities and zeros, aren't you? Now that means that the centre of a black hole is supposed to be infinite mass. Theoretically, obviously nobody's been there, nobody's even been close, because we don't have a black hole. I haven't got a black hole here. You go, there's a black hole, let's measure it. Oh, we can't get to it because it's a black hole. No, black holes are way out there, in, you know, billions of light years away. We haven't got any way of measuring them. And so you have to excuse me if I'm a bit distracted. I've got my van open and people are passing and stuff, pointing and talking. Thinking, oh, that looks nice, I'm going to nick that. Off topic, of course. So anyway, so the point is that as you get closer to the black hole, right, time for you, the person who's getting closer, slows down, right? It's kind of not. Time for you passes at the same rate, obviously, because it's you. Do you know what I mean? But you observing out, you see things happening quicker. Right? Somebody outside looking at you, from their perspective you're slowing down. From your perspective falling into the black hole, you see everything speeded up. Right? So what happens at the singularity, this theoretical construct called a singularity? Well, in reality it isn't there. There is nothing there. Right? Because if you think about it, gravity means that time slows down. Right? So what do you think happens at the singularity? Time is stationary, right? From an external perspective, looking in, you will see pause, nothing, no movement, won't you, at the singularity? But of course, nobody will ever get to the singularity, because to get to the singularity would take an infinite amount of time, wouldn't it? Yeah? So you never get to a singularity, so there's nothing there. There is no singularity, there's no matter at the centre of a black hole, because it would take an infinite amount of time to get the matter there. And so there is none. Right? So what is at the centre of a black hole? Nothing. Because it doesn't exist, effectively. There is no centre of a black hole. Right? So, from the perspective of somebody falling in, if it was possible to see that, right, then if it was you that was falling in, then when you arrive at the centre of the black hole, you know, presuming you haven't been squished, of course, what you would see is a universe that's passing at an infinite speed, of course, because you're at time stationary, so everything else is passing infinitely fast. Right? But of course, that doesn't happen. You don't have infinite time, right? Infinite speed time, shall we say. Okay. So, at the centre of a black hole is nothing. It doesn't exist. There's no actual thing at the centre of a black hole, because if we're talking about the age of the universe with, you know, like the potheads that are following the Big Bang Theory, as they say, is it 13 point something billion years, right? So how close will you get to the centre of a black hole in 13 point x billion years, right? 14 billion years, whatever it is, rounded up. Okay, obviously it isn't an infinite amount of time, it's a finite amount of time, which means that at the centre of a black hole nothing's there, because nothing has had enough time to arrive there, so there's nothing there. So the centre of a black hole is empty. I think probably somewhere the event horizon thing, there's an event horizon thing around it where basically things are stationary at the event horizon. I don't know, whatever, you see. Anyway, so there you have it. What is at the centre of a black hole? Nothing. The centre of a black hole doesn't exist. Okay? So we don't have to reconcile quantum physics with relativity, because there is no infinite small with massive amounts of gravity, because it's nothing there. There's nothing to reconcile. Theoretically, obviously, if you're involving infinite time and zero time differences and things like that, or whatever, I don't know what it is, right, then you could theoretically postulate what could be there, but the reality is in a physical sense, the centre of a black hole doesn't exist. There is nothing there, because there has not been enough passage of time for anything to get there, because you need an infinite amount of time, and of course we don't have that. Infinite speed. I want to distinguish between an infinite time, because, well, what is infinite time, right? So time is something from a stationary time point in the past, or from the infinite past, isn't it? Let's just assume that time is from the infinite past. So therefore, to get to here, in theory, you can say we're in infinite time, because there is no start point in time. So therefore, it's infinitely in the past, which means we're at the infinity fringe, as if it were, you see. So infinite time, you know, for the purposes of this argument, we can say it exists. But it's about the speed, the passage of time. And therein lies the link between gravity and time, because obviously the higher concentration of mass creates higher gravity, which creates a time dilation, doesn't it? It slows it down from an external perspective, doesn't it? Right? So there's obviously a link between time and gravity there. You've got the speed of passage of time and gravity, okay? And there. Now, if you think about it, if you extrapolate that into the past, right, what is the Big Bang? The Big Bang, from a gravitational point of view, is just a huge black hole, isn't it? It's a big black hole from a gravity perspective. It is the entire mass of a universe at a single point. Obviously, a huge, you know, like we're talking about the singularity that created the black hole, aren't we? Right? But if you think about it, if you relate that to what I've just said about black holes, then obviously that's something. We have infinite gravity at a point, so then we have stationary time again, don't we? Now, from our perspective, what that means is that this so-called Big Bang actually happened in the infinite past. So there wasn't actually a Big Bang. It's something theoretically that you know, may or may not have happened, but it's in the infinite past. So from our perspective, it was never there. It never started, because it's always been there. The universe has always been there. It's just been smaller, you know. And as we expand, maybe time will accelerate or something. I don't know. I can't remember which. Slow down or accelerate, whichever it is. Infinite gravity, from our perspective, means that everything passes at infinite speed. So if we're in the Big Bang, you know, we're the Big Bang bit, right, then all of a sudden there's infinite time from somewhere, right? So do you understand what I mean, though? That is a big hole, ironically, in the theory about Big Bang, because they're presuming some sort of a linear time, right? That the time itself is linear into the distant past, and it isn't, of course, because we're inside this universe, and this universe was created from a singularity, wasn't it? And that singularity, from the Big Bang singularity thing, it doesn't exist again, because it's in the infinite past. So from our perspective, although theoretically, obviously, an infinite past, an infinite time into the past, in a mathematical sense exists, but in a physical sense it doesn't. So the universe was never in the form of a singularity. So there you go. So all you cosmologists and physicists who are pursuing all this, you know, Big Bang and seconds before the Big Bang, no, it wasn't. It was millions and millions of years. You're not measuring seconds after the Big Bang itself. You're measuring millions and millions of years, because that time period took millions and millions of years to take, because it was in the infinite past. The actual singularity of the Big Bang was in the infinite past. And so what you're calling 1 second after the Big Bang, right, is just a fringe event, as if it were, but that fringe event took millions of years. Billions. And the universe is infinitely old. Ba-boom. So, physicists and cosmologists and quantum physicists. I defy you to find a problem with that. I defy you to find a problem with that logical argument. And you heard it here first.